along with its thick size and strange shape, like a slice of honeycomb stacked on a pile of pancakes. One of the most striking things about the Webb Space Telescope is its lustrous gold mirrors. They look like they're made of gold for a very good reason. They are. Given that the telescope cost $10 billion so far, you might imagine that the mirrors are solid gold. NASA could certainly afford it. They're so loaded with fat stacks that they're the 1% of astrophysics research institutions. The mirrors are actually made of a toxic wonder metal called beryllium, then coated with a layer of gold about 120 nanometers, roughly 3,000 atoms, thick. Even though the 18 hexagonal primary mirror segments have a total surface area of 25.44 square meters, 274 square freedoms, less than 2 ounces of gold was required to fully cover all of it. We mostly think of gold as a commodity that used to back our now fiat currency, a status symbol for the extreme ends of the class spectrum, or a ghastly commemorative coin. However, gold has physical properties that make it great for optical instruments like telescopes. Most metals rapidly react with the atmosphere, oxidizing, tarnishing, and degrading their finish. But gold is inert, doesn't react at all. A gold surface will remain as pristine as the day it was made, forever, so long as you don't dig it up. And it's soft, so we'll see in a minute that they take precautions. Gold is also a spectacular infrared reflector. We don't make bathroom mirrors out of gold because it doesn't reflect blue and green well, but it does reflect larger wavelengths, what we see as yellow, orange, and red, very well. At larger wavelengths still, in the invisible infrared, it reflects more than 99% of all the light that hits it. This makes it extremely efficient for a reflecting telescope. All modern large telescopes are reflecting designs, not glass-lensed refractors, which is a whole other discussion. The bottom line is that a nearly perfect gold surface reflects all light to precisely the same focus, whereas glass loses a little bit of light and sends rays of different colors slightly astray. The largest refracting telescope in the world, with 40-inch diameter lenses, was built in 1897. Webb has roughly 30 times more collecting power, and ground-based scopes may have as much as 100 times more. The extreme reflectivity of the gold mirror surface carries a subtler benefit. Everything in the universe, including the universe itself, glows with light. The brightness and color of the glow vary with how hot the emitting surface is. Our bodies glow with the large infrared wavelengths that Webb's mirrors collect. That's actually how ear thermometers work. If the mirrors themselves are heated by sunlight or the electronics that power them, they will glow too. Imagine if you were using a backyard telescope to observe the stars, but it was hot enough to glow red. Sure, the extra light contaminating your image would be the least of your worries. However, surfaces only glow in proportion to how well they absorb light. Dark and rough surfaces like carbon and soot glow brightly, while smooth and shiny surfaces do not. As a near-perfect infrared mirror, gold absorbs almost no light at these wavelengths, hence it glows very little when it gets warm, reducing background light in its images. The bodies of the mirrors are made of beryllium, not solid gold. Beryllium is an aerospace material that is very stiff, very stable under heating and cooling, and very light. Unfortunately, it's also incredibly expensive and toxic to people who become sensitized to it. The beryllium substructure lays a good foundation for the mirror's gold surface layer. The microscopic coating is applied by boiling solid gold and allowing the vapor to deposit on the beryllium surface. Careful coating craft allowed the surface to be made smooth down to 250 atoms or less. The gold is capped with a fine layer of glass to protect it from scratches and allow it to be more easily cleaned. The final mirror surfaces can reflect nearly every ray of light, prevent thermal glow, and maintain an extraordinarily smooth, clean finish, effectively funneling photons into the telescope's instruments to produce the images at which we routinely gawk. I hope you found this video informative. Please stay tuned for more upcoming videos on other interesting aspects of space, science, and technology. Have a good one.